Hey everyone, and welcome back to another video. It's the Somewhat Tutor, and today we're going to be looking at simultaneous equations. This is going to be the first part, and the second part we're going to be using a slightly different method from today, and that's going to be substitution. But let's get straight into it, and let's start by looking at some examples. So as the first one, we've got 2x plus y equals to 10. And then we've got x plus y equals to 4. So we've got two equations, but let's just start out by numbering them. So we've got 1 and 2. When dealing with substitutions in a very simple form like this, where we've got no power terms, we've just got single isolated powers in x and y, we can use what we call the analogy of DASS, or D-A-S-S. So what that means is difference you add, and if it's the same you subtract. So what does that mean? In a sense, we're just looking at these two operators here. So if they are the same, so they're positive and a positive, we have to subtract the equations. So if they are different, for example, if it was a positive and a negative, we have to add the equations. But it's really important to note, when we're either adding or subtracting, we want to eliminate one of the two variables. So we can only eliminate them if they are of the same magnitude. So for example, in this case, we've got a single variable of y and a single variable of y. If we in this case, because they're the same, we subtract, so we take a 1y minus a single y, that equals to 0. But if they were different, which we'll show in a later example, we may have to multiply the equations to get a common factor. So in this case, as we've already got a common magnitude of single y and a single y in both equations, and we know it's the same sign, we have to subtract the equations. So we've got 2x minus x, which leaves us with a single x. So 2 minus 1. We've got positive y minus positive y. Again, they will just cancel through. So that leaves us with nothing. And then 10 minus 4, which is 6. So brilliant. We've already got our single value of x. So that is x equals 6. And what we're going to do with that is substitute x equals 6 into any equation you like. So let's just go with equation 2. So we've got x equals 6 plus y equals 4. So what we're going to do is minus 6 from both sides. So we've got y equals 4 minus 6. Y equals minus 2. So we can check that by substituting x equals 6 and y equals minus 2 into any equation. Let's just do equation 1 as we've not used it yet. So 2 multiplied by 6 plus minus 2 should equal 10. So we've got 2 times 6, which is 12, minus 2, which equals 10. So that's a tick mark and it works out. Right. Now let's do a different example. Let's do another example. So bear with me a second while we set up. So let's do example number 2. We got 4x plus 3y equals 14. And we've got 5x plus 7y equals 11. So we'll label that equation 1 and equation 2. Again, we use the analogy of DASS, DASS. So we've got the same sign, so we must subtract. But remember, in the previous example, we had the same magnitude of y, so we could minus a positive y from a positive y, leaving with 0. But in this case, if we do 4x minus 5x, that's negative x. 3y minus 7y is negative 4y. So we can't eliminate any variable. That means we must find a common factor. So we could either get the same magnitude of x, or we can get the same magnitude of y. It's really up to you. We just have to find the common one, and that's usually by just taking the coefficient of any y or any x and multiplying it by the other. So that might sound a bit complicated, but it's really simple. So for example, let's say we want to have a common x variable. For equation 1, we just take the first number of equation 2, which is 5, we times it by 5. And then likewise for number 2, we take the first coefficient of x, which is 4, and we times it by 4. So if you do 4x multiplied by 5, that's 20x. And if you do 5x multiplied by 4, that's 20x. Can you see how that's the same, and that would cancel through? So 20 minus 20 is 0. But likewise, we could do the same with the y's. We could do 3y times the 7, which is 21. And for equation 2, we could do the 7y multiplied by 3, which is 21. So the y's would also cancel out. So in this case, we're just going to cancel through the x's. So let me just rewrite that as 20x plus 15y equals 70. And then we've got 20x plus 28y equals 44. And we're just going to name these new equations as 3 and 4. We've again got the same sign, so we can cancel through as it's subtracting. So 20x minus 20x should cancel through. We've got positive 15y minus positive 28y, which is negative 13y. And that equals to 70 minus 44, which is 26. So what we're going to do then is divide by 13 to isolate the y from both sides. So minus y equals 26 divided by 13. We can clean that up as minus y equals to 2, and then y equals to negative 2. What we can do is then substitute y equals minus 2 to any of the 4 equations as you like. But let's go for a smaller magnitude and sub y equals minus 2 into any equation. Let's just do equation 1. So we've got 4x plus 3 negative 2 equals to 14. 4x, expand that out, that's minus 6, a plus and a negative has to be a minus, that's minus 6 equals 14. So what we're going to do is add 6 to each side to eliminate the x here, to eliminate the minus 6 and to isolate x. So we've got 4x equals to 20. We're going to divide both sides by 4, which is 20 divided by 4. Again, that equals to x equals 5. And we can check that by substituting y equals minus 2, x equals to 5 into equation 2. So it should work out. Let's do that. So we've got 5 multiplied by 5 plus 7 multiplied by minus 2. Sorry, that's a minus 2 equals to 11. Let's check it out. We've got 25 minus 14 equals 11. So therefore, that's a check. Right. So hopefully that's made a lot of sense. But let's just drill it down and do one last final example. And that's going to be using a different sign. So we've got an example of 3x plus 2y equals to 17. And then we've got as equation 2, 4x minus y equals to 30. So we've got equation 1 and equation 2. So again, using the analogy of DASS, D-A-S-S, we've got a difference in the sign. So we've got a positive in equation 1 and a negative in equation 2. We have to add. Difference means we add. But remember, we must eliminate a common factor. So if we do 3x minus 4x, that's negative x. Positive 2y positive 2y plus minus y, which is a positive y, we don't eliminate either an x or a y. So what we can do, just by looking at this, we can say, well, here we've got a positive 2y. We can get a common variable in y by multiplying equation 2 by 2. Now we don't have to do that. We could do a common x variable by multiplying equation 1 by 4, because it's the common one, coefficient. Sorry, it's the coefficient in equation 2, and then we can multiply equation 2 by 3 because it's the coefficient in equation 1. But let's just multiply by 2 to eliminate the y's this time. So taking equation 1, let's just rewrite that as a 3x plus 2y equals 17. And equation 2, which is now multiplied by 2. So we've got 8x minus 2y equals 30. And that's the new equation 3. We're going to be minusing this. So we're going to be adding this because it's a difference in the sign. So we've got 3x plus 8x, which is 3 plus 8, which is 11. A positive 2y, add a negative 2y equals the same as positive 2y minus 2y, as a plus and minus is equal to a minus, and that's equal to a 0y, which is 0. So that cancels through, we're leaving us 11x equals to, this should be a 60. Let me just rewrite that as 30 times 2 is 60. That should equal to 77. So getting x, isolating x, we can do this by dividing both sides by 11, which is 77 divided by 11, x is equal to 7. So now let's sub x equals to 7 into equation 1. That's because we haven't used it. So we got 3 multiplied by 7 plus 2y is equal to 17. 3 times 7 is 21 plus 2y is equal to 17. So we've got 2y is equal to minus 4y is equal to minus 2. Brilliant. So we can check this by substituting x is equal to 7 and y is equal to minus 2 into any equations. So let's just do into equation 2. So we've got 4 multiplied by 7 minus 2 is equal to 30. So we've got 28 positive 2 minus and a minus is equal to 30. So brilliant, that checks through. So hopefully that's made sense and you've enjoyed this video. What we're going to do next is do simultaneous equations by substitution, my preferred method, as that allows us to work with these sorts of equations and equations with powers. So if you've enjoyed this video, please do like, comment and subscribe, and I'll catch you next time.